Okay. So the then questions are, the first one is, it's a word problem. You need to approach with your common sense, whether you need to add or subtract, then figure out what might be the answer. So the Janet has 17 quarters. I think you already know how many quarter makes a dollar, so you need to recalculate them. Be careful if it's 5. Okay.
3.
So the next question is again like missing 2 numbers. So which 2 pair numbers can make this? Like the top one is when you multiply those numbers, it has to be on the top, and when you add them, it has to be the number on the bottom. Okay. And the last one is, it's just it's not a real math question. It's just a kind of, you need to figure out how many squares in this shape. But be careful. If you say 9, you might be reconsider your number. So yeah. So think about. And the last one is perfect square. If you don't know perfect square, it's just checking your last year knowledge about perfect square numbers, composite numbers, prime numbers. So see if you can remember about perfect square number. Okay. And we will start about 2 minutes. Thank you for the attendance. Okay, last 20 seconds. Which question do you think you need help? Last one. Okay, just a little clue about the last one. Which number you can represent? There is a couple numbers, right? 25, 15, 6, 16, 27. Only one of them is perfect square. Perfect square numbers are the numbers that when you multiply a number by itself,
15.
you cannot rewrite 15 like something times something. Like those numbers has to be the same thing. For example, 9 is a perfect square number, which is 3 times 3. So you're multiplying by itself. But there is no 9. So you need to think about other numbers. What number, if you multiply by itself, you're going to get one of these numbers? 15? Class, okay? And about the Zoom sessions, in case if you miss any lesson, I would highly recommend to watch the videos that I'm posting on Google Classroom. It's because every lesson that I'm teaching is kind of builds like one lesson to the another one. So try to not to miss the lesson, and especially try to stay at least until I finish the I do part in the lesson, because I do part is the main part of the lesson that I teach and the part that you need to learn. Okay, so now we can start. We have still coming participants. Okay, so good morning. Today's agenda is we're going to start with Dan, and hopefully everybody finished this. In case you didn't finish, you can finish up later. It's just the review questions. And today's lesson is we're going to talk about addition and subtraction, but this time not addition and subtraction of integer numbers. So we're going to talk about new types of numbers, and we call this rational numbers, or another way we just can say like rationals. Okay, this is a new type of number, and I'll explain, and this is very important part of this lesson. And there is a 2 IXLs that we can do this in this Zoom session, and there is a 1 exit ticket at the end of the class, and this is all for today. Okay, so today's objective is you can say at the end of this lesson, I can recognize that the rules for adding and subtracting integers apply to the rational numbers, which means, so we learned the rules for addition and subtraction for integers, right? It's the same rule. This time we're going to apply on the rational numbers. Rules are not changing. Only the numbers are changing, but the rules will be the same for rational numbers too. Okay, so we're going to talk about this today. And so let's start the lesson on the I do part. So what are the rational numbers anyway? And we heard it a lot, like be rational, kind of in our everyday life. What is actually in math rational numbers? So we started with the counting number beginning of the school year, right? Like reviewing. We already know this stuff, but we need to know the big picture. So counting numbers was the numbers that we count in everyday life, like 1, 2, 3, 4, 5, and goes forever. And the whole numbers are when you include 0 to the counting number, and we call those numbers whole numbers. Okay, this is a little bit difference between counting and whole numbers. And also, we started to learn this time integer numbers. Integer numbers are like negative side of the, like includes negative side of the counting number. So for example, these blue numbers are counting number. If you include negative of those numbers, like -1, -2, -3, and including 0 also, so we call these numbers integers. Okay, so it's getting like our number family are getting bigger and bigger. So and there is a specific things that on the number line, the numbers on the right side, we call them like positive integers, so which is the same thing on the right side of the number line. Negative integers was on the left side of the number line, so those are the numbers on the left side of the 0. So these are the numbers that we learned till today. And also, there is a couple more things we need to know about numbers. So there are decimal numbers. This is the one other type of the number. Decimal numbers are basically the numbers that you put like a point, and there is a hundredths, tenths, or thousandths place numbers, right? So these are the decimal numbers, and decimal numbers also could be negative. So this is the tiny different detail about decimals. So decimals can be positive or negative, but it looks like this. And you also learned before fractions. The fractions are like something over something, or numerator over denominator. So those kind of numbers like 1/8, 3/4, and this is a mixed number, by the way, 2, 3/4. So those kind of numbers, we call them fractions, right? And fractions also can be negative. So this is the one example. I'm not sure if you learned percents, but the percent number is also kind of numbers like regular numbers. The only thing you're going to see at the end of the number, like this sign, like a two circle, and in the middle of the circle there is a kind of slash. Okay, so these kind of numbers are percent numbers. So we're going to talk about this more when we go in a percents unit. Okay, so we call like all these numbers, like the numbers that we know, I can say, we call them, we gave them a general name. So we call them like our rationals. Okay, so you can remember the type of number I know until today, we call them rationals. Okay, which means we learn the rules and we will apply for those rules, not for only integers, for all of these type of numbers. Okay, and one question might come from you, like, okay, we call these all numbers rationals. Is there opposite of rational number? So like in the language, we say it like opposite of rational is irrational, right? We make it like negative, irrational. So here is the example for irrational numbers, if you know. For example, there is a little, what do you call, comic? It says, don't think that you guys should stop fighting. You're both being irrational. It's just an example. So the opposite of rational, we call it irrational, and irrational numbers are kind of pi number, if you know this. I think on the other class, somebody were telling me, I know pi number. So this is an example of irrational number. It's not belong one of these groups. So it's irrational. Or square root numbers. For example, square root 2. It's irrational. It's not belong one of these type of numbers. So these are the examples of pi and square root 2. And 8 is irrational. That's why he's telling the other two guys like, hey, stop being irrational, because he's a rational guy. Number 8, because number 8 is integer, number 8 is whole number, number 8 is counting number. So it belongs one of these these groups. Okay, so this is about rational numbers. So all you need to remember the numbers that I know until today. Okay, so those numbers we call it rational, just the general name we gave for all these numbers. Okay, so this is about the very important part of the lesson that you need to remember, or you can make a note if you have a notebook that you're taking, or you can save this slide somewhere in your computer, I would say. And the second thing, we talk about the rules for integers. But this time we apply these rules for rationals, not only for integers. We're gonna broaden our knowledge into like more wider context, okay, in rationals. So let me just quickly review about the rules for integers. So there is an addition rule for addition rule for integers. So the rule was same sign numbers will be added and put front the common sign, right? So for example, if you have a two negative numbers, actually you add those numbers and put negative sign in front of it. Or if you have two positive numbers, when you're adding them, you're gonna add the numbers and put the positive sign in front of them. So here's the examples. For example, 4 and 5 is positive numbers, and when you add them, so because of both numbers are positive, your result is also positive, and you just need to add the numbers. Like 4 plus 5 is 9, so it's obvious. And it's for the same thing for negatives. So first number is negative, second number is negative. When you add them two, you just need to add 6 and 2, which is 8, but you need to put the common sign, which is negative sign. So the result has to be also negative. So this is the addition, like first rule for addition. And there is a second rule, and it's about the opposite sign numbers. So you're not always adding same sign numbers. Sometimes you add opposite sign numbers. And when you do that, so you need to subtract those two numbers, like for example, 6 and 2. I'll give you an example on the bottom. So you need to subtract them and put front larger number sign. So the key point is you need to see which number is larger than another one and put that sign in front of them, okay? So for example, so the first number is negative, second number is positive, 9 is greater than 3, and the sign of the 9 is positive, so that's why my result has to be positive, and you need to subtract them. So 9 minus 3, it's 6, and I put the larger number sign in front of them, okay? And another example is negative 7 is negative number, 4 is positive number, but my larger number is 7 compared to 4, so I'm going to subtract them, 7 minus 4, which is 3, but I will put negative sign in front of the result. So this is the key point about addition rule, okay? And about subtraction rule, there is only one rule for subtraction, and there was a statement, if you remember, I told you, like, if you understand the statement well, that means you understand the subtraction perfectly, okay? So the statement was subtracting a number is the same as adding its opposite. So if you subtract anything, actually it's the same thing adding that number of its opposite, okay? Let me show you an example. For example, so 8 minus 3, actually it's the same thing adding of this. For example, the 3 is positive number, right? Adding its opposite. So positive, opposite of positive 3, it's negative 3. So adding negative 3. And you ended up the same result, 5. So 8 minus 3 is 5, or 8 plus negative 3 is 5. If you don't believe, you guys can check on your calculators. It's the same thing. So this is the meaning of this statement, okay? And another thing, 1 minus 9. Sometimes like you subtract bigger number from smaller number, and you'll end up with negative number. So subtracting positive number or subtracting positive 9, actually it's the same thing adding opposite of positive 9, which is negative 9. So you ended up the same thing with negative 8 for both cases, okay? And the last one is sometimes you subtract a number from negative number, so it looks like two negative signs. Actually, this is a different. So this negative sign belongs to 4, which is, this is a negative 4. This sign is actually subtraction, not the sign of 5, because 5 is positive number. So operation versus sign, those are different things. I know it's kind of confusing, but if you practice more, you'll understand the difference between these two, okay? So the point is, subtracting positive 5, it's the same thing adding opposite of positive 5, which is negative 5. So like we know addition rule, like when we add the same sign numbers, we just need to add the numbers, right? The 5 and 4, which is 9, but we need to put the common sign. So both are negative, so result is negative. It's the same thing for in both cases, okay? You ended up the same negative 9 all the time. So this is the subtraction rule. And also, oh, there is one more case actually. So I'm trying to give like every different cases that you can encounter, you can see in your life, I would say, until you graduate from college, I would say. So those are the different cases that you may see all the time. Like subtracting smaller number from bigger number, subtracting bigger number from smaller number, subtracting a number from negative number, or subtracting a negative number from negative number. So those are the all different cases that you may see about subtraction in your life. So the last one is also subtracting -7. It's the same thing, adding opposite of -7, which is 7. So, and we know this, like opposite sign numbers, when we add them, we just basically subtract one from another, but we put the bigger number sign. So 7 is bigger than 2, which is +5. Okay. And the last thing we learned on the last week about distance between two integers. So it was like just the absolute value of their difference. So when you have two numbers, and if you're trying to find the difference between those two numbers, the meaning is distance. Meaning of distance is just subtracting one from another and taking absolute value of that result. So here's the example. So distance between -3 and 4. So this is the two numbers. Actually, if you subtract them like -3 minus 4, and it's going to be -7. And if you take an absolute value of the result, which is 7, and you'll find the distance between these two. So which is 7 units far away from each other, these two numbers. Okay. So these are everything we learned till today. And I felt that we need to review this before we move on, before we apply this knowledge into the rationals, because every time when we say like an integer, now we're going to replace with rationals, which is like a more broader context. Okay, like we include more types of numbers. And next thing is example of adding and subtracting rationals. So now let me give you a couple more examples like what I mean. And don't be afraid. So we're not doing this like by using the way we did in the 6th grade, because we have calculators now. I'll show you like how to type mixed numbers on the calculator, how to type decimal numbers on the calculator, so or any percent numbers. So everything will be easy if you know how to enter these all these types of numbers on the calculator. Okay, so let me give you one example. So the example is, let's start with this word problem. Suppose a 7th grader's birthday is today. Let's say like one of your in this classroom, or the students who's listening to us right now has a birthday today. And yes, she's 12 years old. Assume that she's 12 years old. How old was she 3.5 years ago? So what do you think her age is 3.5 years ago? So we need to write an equation and use the number line over here to model our answer. Okay, so let me explain this. Hold on, let me grab my pencil. Here we go. So my first number is 12. So I'm going to write my equation 12. And because of how old was she years ago means like we need to go back in the time. So going back in the time means we need to subtract this positive number, right? So it's going to be -3 1/2 or 1/2. So this is a mixed number, by the way, and equals. We need to find the answers, and when we find the answers, we need to use this number line. Another thing about number line, so not all the time you will see the labels on the bottom. In all examples, I put the labels, right? But sometimes you're not seeing the labels. In that case, you need to come up with your own creative way to label these numbers. So I would recommend when you start labeling your number line, always start locate your 0. So I'm going to locate my 0 right here. Could be in the middle, could be in this spot, any spot that you can locate them. Because if you know where is the 0, it will be easy for you to find 12 and 3.5. Okay, so if this is a 0, but 12 is a very big number, I don't have enough 12 units, right? So if I increment my numbers like by 1, so 1, 2, 3, 4, 5, 6, 7, 8, I'll end up with 8, but I need a 12. So because of that, you have to be, again, a little bit more creative, or go with like a by 2, increment by 2. For example, 0, 2, 4. Did you see, guys? And what is the next number? 6. What is the next number? 8. And what is the next number? 10. And what is the next number? 12. Woohoo, I got it. So I made it in the number line, so which is great. So sometimes, like if you don't have enough spot, you need to start incrementing your numbers by like by 2 or by 3 times sometimes, or by 5 sometimes. It depends the situation. So the reason why I located my 0 on the left like little bit this side of the number line, on the left side of the number line, it's because I have a bigger number 12 and I need to put inside of the number line. Okay, this is a tiny detail about labeling number line. So let's go back to our now subtraction. So we need to find a 12, right, on the number line, and we got it. It's over there. It's right here. And starting at 0, let me use arrow this time so everybody can see this clearly. So starting at 0, I need to go till 12, right? Can you guys see this green line? Yes. Okay, so here's my first one, 12, but it's subtracting 3.5. Means, so this time we need to be kind of careful about making like a half. So you may say, hey, mister, I cannot see the half. But again, you need to your common sense in this one. For example, right middle between 10 and 12, it's 11, right? So right middle between 8 and 10 is 9. And I think that will be enough. So now let's, let me grab another. So let's go with this color this time, and let me grab my arrow. So I left at 12, right? Now I need to start at 12 this time. So I'm gonna label my right here. So this is 1 to the left because it's subtracting 3.5. This is 2, and this is 3. When I come to the 9, it's like this point. I come like a 3 units backward. But there is a 1/2, means like I need to go half also, not like whole unit. If I go till 8, I'll go like 4. If I stay at 9, I'll be 3. But I need 3.5, which is I need to stop the end of the. Let me grab this line. This is the end of the where I stopped between 8 and 9, because this is a half. We count this half. Okay, so your final destination would be what? So 8.5. Okay. So let me grab my pencil again and go back my red color. So this is my final destination, and final destination would be our result, right? All the time. Okay, so it's an 8 between 8 and 9, which is 8.5. So either you can say 8.5 as a decimal, it's fine, or you can just say explicitly like as a fraction, 8.5, like 1/2. Okay, so both are correct. So this is an example for rational numbers about subtracting like two rational numbers. I mean, not integers this time, because first number is integer, second number is fraction, and both are in the category of rational numbers. Okay, so and I'm going to show you the examples on the bottom now. So these 4 examples by using my calculator. Okay, I know we don't. It's very hard all the time using a number line for half, 1/4, or 8.4 or 0.9. We don't have such a number line all the time. That's why we have a calculators. That's why it's allowed for us to use a calculator. So let's start with first now -2.5 plus 5. So let me show you how to type this mixed number on the calculator. Okay, I'm going to stop real quick my sharing my screen, and here's my calculator. Here we go. So what was my 2.1/2 and plus 5? So here's the calculator. I'm going to show this one. If you guys have a different calculator, let me know. I will show on that one too. So turn on your calculator, and if you look at your calculator, almost all calculators has that function. So did you see this? Like A, oops. Let's clear this button. It says A, B over C, means like a mixed number. When you type something, actually it's going to count as a whole number. When you type and another like this button, it's going to take you to the numerator. And if you click one more time, it's going to take you to denominator. So now, because of the first number was negative number, I need to start typing this number, this sign. Okay, -2. Click once, 1, click second time, half. What was the plus? Plus 5. Okay, so as you see, like 2 is whole, 1/2. This is 2 1/2. We call this, okay? And plus 5. when you type all these operations and numbers together and just hit the enter, you're going to end up. So this sign is actually tells the in front of that sign is actually the whole number. So 2 1/2. So result is positive 2 1/2. So let me go back, sharing my screen again, and share my screen. So let's type our result over here. Okay, so the result was 2 whole and 1/2, right? And let's try another example. 1 minus 2 1/4. 1 minus 2 1/4. So stop it and clear out. It was 2 minus. Oh no, 1 minus 2 1/4. Let's clear out. 1 minus 2. I'm going to keep clicking this. 1 and I keep click again and 4th. Okay, so I'm subtracting integer. I mean mixed number from integer number. So when you hit the enter, you're going to end up seeing this. It's a negative 1 whole and 1/4. Okay, so this time I obtained negative result. So let me share my screen again and let's put it negative 1 1/4. So our result would be negative this time 1 1/4. Okay, and so we're going to do these two also on the calculator. Let's keep practicing. And negative 1 1/2 minus negative 8.4. So now this time we're going to practice with decimals and fractions. Okay, so all of them are rationals. So let me stop sharing my screen. Negative 5 1/2. Negative 5. Keep click this 1. Keep click this second. Negative 1 5/2 minus it was negative 8.4, right? So this dot is actually tells you the decimal point. Okay, so when you hit the enter, you're going to see 2.9. So it becomes positive number now. It gives us the result as a decimal number. It's okay. So unless the problem says you need to write your answer as a fraction or decimal, you can put any kind of type of number, okay? So don't worry about it. Oops, did I share my screen? It's a 2.9. Okay, I didn't share it. And let's go back. And my pencil was at 2.9. Okay, and the last one is 7 minus 0.9. So we can do this, like let's try to do this mentally now. If you remember, when two negative signs meets together, it becomes positive, which is, this is a 7 plus 0.9, right? Sometimes you can do it like fastest way, or you can type on a calculator too. So I know that the whole part of this number is 0, so 7 plus 0 is 7. And you need to put the decimal part because the first number doesn't have a decimal part, so which is just a 9, so 7.9. Okay, so these are the adding and subtracting rules, like when we apply on the rationals. Okay, easy, like how to typing these numbers on a calculator. I believe everybody can do this. Okay, so remember about the growth mindset on the first week. So now let's see what we have on the next slide. So this is today's lesson, by the way. This is the I do part that I really want you to listen. Now we do part is kind of now, thank you. So there is a word problem. Also, this is also like owing $7 means like -7. Got paid like 5 and 50 means like plus that number. So you need to figure out what would be like in a real life example. As you see, like 7 is integer, 550 is decimal number. So we call them both together rational. Okay, these are the kind of examples you may see in word problems. This is a money problem, by the way. Okay, and there is another problem about the car trip, like a gallon of gasoline they have, and they consumed like a 10 1/8. So as you see, this is a mixed number. So try these problems by yourself. Let me know if you got the answer, or put your answers in your own slides. I'll check them later, okay? And another one, and we're going to move on. There's a two practice with IXL, C4 and C9. Try to get like as close as 70. I mean, if you know how to use a calculator, you can finish up very quick, I believe, because it's the same rule, it's the same calculator. The only thing you need to know how to type the numbers on the calculator, and negative numbers also. Be careful. Okay. The second one is hard. We can do during the intervention time together. Okay. These practices. So before you go, by the way, do the exit ticket. it's on the last slide, and I'll see you on the next class. It's just a self-reflection. Just one problem. Actually, it's not a math, it's just a creating equation, and about how you were good in participation, and you're good to go. Thank you so much.